Hello everyone, I'm Xintan, a PhD candidate from Peking University. Welcome to the presentation of our paper, Scaling Open Source Communities, an empirical study of the Linux kernel. Large-scale open source communities, such as the Linux kernel, have gone through decades of development, substantially growing in scale and complexity. Since version 4.5, there are 79,000 change sites from more than 4,000 developers. The original workflow cannot adapt to the current volume of patches. It has triggered heated discussion. Even in other projects, this issue also occurred. The codebase of the Linux kernel is organized into many subsystems. Usually, each subsystem has a maintainer who has commit right and is responsible for the quality of patches. The patches are selected and transferred by the maintainers layer by layer until they are merged into the mainline repository. This workflow makes the first layer maintainers face heavy workload and the risk of single point of failure. Some subsystems attempted new workflows to resolve the crisis. A typical one is multiple commit model. Let's call it MCM. It was firstly applied by the INA15 subsystem in October 2015 and seems to work well. The core idea of MCM is distributing the workload to a group of contributors by giving commit rights. However, there are many doubts about MCM because delegating commit right is a risky operation. In fact, delegation has been extensively discussed in the literature. However, the old licenses are enriched in response to the new challenges of the time, such as abuse of commit rights. In order to help more projects with scaling issues, we designed two research questions. The first one, to what extent does the MCM work? Second, how to apply the MCM? There are two sub-questions. What factors are crucial for successful implementation or operation of the MCM? The next is, how should candidate committers be selected when maintainers adopt the MCM? This slide gives an overview of our study. We did an empirical study on the Linux kernel. We combined a quantitative approach and a qualitative approach to answer the question. To validate our findings, we conducted email interviews inside and outside the Linux kernel. To evaluate the effect of MCM, we obtained the commit history data of the INA15 subsystem and identified the review workload of the maintainers. We also designed 8 metrics belonging to 4 dimensions. Maintainers' pressure is measured by how much review work they have done. Latency measures the length of time to review a patch. Complexity measures the complexity of review work reflected by the number of different authors and fields related to a patch. Quality assurance measures the effort to deliver quality. To find factors for the successful implementation of the MCM, we searched the relevant online documents and applied semantic analysis. The approach to select candidate committers is inspired by the findings about crucial factors. Considering the 2 factors related to committers, for subsystem, we can construct its collaboration network. Based on this network, we can find candidate committers. The details of this approach will be introduced later. Now let's see the results. These figures show the changes in measurements before and after adopting the MCM. It seems that all the metrics change after applying the new model. To evaluate whether these changes are significant, we did a statistic testing. Except the M6, all the metrics are significantly changed. Therefore, we can conclude that after the adoption, pressure on maintainers, review latency, and the complexity of review relationship between maintainers and patch authors were significantly reduced, whereas the workload is more dispersed. At the same time, the new model enforces a strict process to ensure patch quality. We also fitted regression models to test the scalability of the MCM and found it scales well to allow more committers. We identified 7 factors that are crucial for applying the model. The projects with overloaded maintainers and a single point of failure are the targets for the MCM. To select appropriate committers, candidates should be capable and share trust with maintainers and other committers. In addition, a set of measures to mitigate risk is very important. According to the characteristics of committers, we built the collaboration network of the N15 subsystem. We can see that the developers with close relationship were elected as committers. Therefore, we propose an approach to select candidate committers by locating the featured dentist subgraph. In the validation, we focus on the second research question and validate whether our findings can apply to both inside and outside the Linux kernel. Therefore, we did email interviews with the top 50 busiest subsystems in the Linux kernel and the Node.js project. The opinions confirmed our findings, and some are very interesting. Because the time is limited, I won't go into details. There are some take-home messages. MCM is effective to deal with the scaling issues of open source communities. Delegating commit rights needs supervision. Having capable and trustworthy committers, a series of measures to mitigate the risks. Thank you for your kind attention.